matrix. Matrices are 2D arrays, okay, which has m number of rows and n number of columns. Okay, matrices are 2D arrays which has m number of rows and n number of columns. Let me take two simple matrices. Okay, I will take some 3 by 2 matrix or 2 by 3 matrix, anything. Okay, 1, 2, 3. Okay, I'll take one more element also. 4, 5, 6, 7, 8, 9. The next row is, okay, let me give sufficient gaps so that it looks like a matrix to you. Okay, 11, 12. Okay, so what is the dimension of this matrix? This matrix is 3 by 4. This is a 3 by 4 matrix. Let me take one more matrix. Okay, the matrix is 10, 11, 12. I'll take the same dimensional matrix, 13. Okay, 14, 15. Next element is 17. Okay, I'll take one more matrix, 18. One more row, 19. Okay, the last element is 21. Okay, so these two are 3 by 4 matrices. Okay, let me name these matrices. Okay, let me call this matrix as X. What is the dimension of X? 3 by 4. Let me call this matrix as Y, which is also 3 by 4 matrix. What are the subscripts? This is column 0, 1, 2, 3. Because you have 4 columns, the subscript ranges from 0 to 3. Similarly, row, I have 3 rows, so the subscript ranges up to 2. Similarly for this also, column 0, 1, 2, 3. Okay, this is row 0, 1, 2. Okay, suppose I want to perform the addition of these two matrices. That means I want to perform this matrix X and matrix Y, the corresponding elements we want to add. The corresponding, what is the addition of matrices? The corresponding elements we have to add. Okay, so here 0, 0 element, I have to add it to here 0, 0 element. The element 0, 1, we have to add it to the 0, 1 element of Y. 0, 2 element, I have to add it to 0, 2 element of Y. Similarly, this. Similarly, for the next row, I have to add these two, 1, 0 of X and 1, 0 of Y. Similarly, 1, 1 of X, I I have to add it to 1 of y. Okay. Similarly, 1 2 of x I have to add it to 1 2 of y. This I have to add. Similarly, each row, the corresponding elements I have to add. Each row, corresponding elements we have to add. Okay? How many rows are there? How many rows are there? Okay, I have 3 rows, 4 columns. What is that I am doing in every one?
This conference
Okay,
will now be recorded.
so what will be the, are you able to hear me? Okay, so I'll create a new matrix called Z. Okay, Z. What will be the dimension of Z? If X has a dimension 3 by 4 and Y also has a dimension 3 by 4, the sum of these two matrices, the corresponding elements of these two matrices will also have the same dimension. Okay? So Z will also have dimension of 3 by 4. What is each element in this? So here 0 0 element of x, that is, and the 0 0 element of y, that I have to sum up. Similarly, 0 1 element of x and 0 1 element of y. 0 2 element of x plus 0 2 element of y. Similarly, 4 plus 13. Similarly, the second row, 5 plus 14 corresponding elements. 6, what is the corresponding element? 15. For 7, what is the corresponding element? 16. For 8, the corresponding element is 17. Similarly, do for the next row. 9 plus 18, 10 plus 19, 11 plus 20, 12 plus 21. 21. Okay? This I have to perform. I'll write this again because it is not very clear. Okay, what is the last element? The last element is, okay, 12 plus 21. Okay, this I have to do. So, what is Z of ij? Because same dimension will be there in the resultant matrix also. Z of I and ith row jth element is equal to x of ith row jth element plus the corresponding element of y I j. This is what we are doing. This is what you are doing. How many times you are doing this? How many times you are doing this? Okay, for all the rows. That means for I is equal to 0, I less than or equal to m. What is m? M is the number of rows. I plus plus. This is for each row and then for each column of the row. For j is equal to 0, j less than or equal to n, where n is the number of columns, j plus plus. So, how many times this summation is performed? For each row and have n number of columns. So here I'll write M is the number of rows, M is small m is number of rows, number of rows. Okay, similarly, what is n? N is number of columns. Okay, for m number of rows and n number of columns, I am doing this nested for loop. How many times this summation is executed? How many times this summation is executed? Because this summation, this assignment is in the nested for loop. This loop is executed. This loop is executed how many times? M times. Okay. And for each value of I, for each value of I, how many times this loop? N times for each row. N times for each row. So this summation is available in inner for loop. So n times for each row. So totally how many times this summation is executed? Okay, this summation is executed. I have m rows and for each row n times it is executed. Is that clear? Okay. Okay, let us write the program. So you remember? So the resultant matrix is also of the same dimension. It will have m rows, n columns. Each value is obtained. This value is obtained by how this value is obtained? By adding the corresponding elements of the two matrices. Okay? Let us write the program. Okay. Hash include the standard output input output header file. Write the main function. Okay. Now how many rows, how many matrices we are taking? See here, X is one matrix, Y is one matrix. Okay. So what is input to our program? So addition of two matrices, addition of two matrices. Now let us write down the steps. What is input? What should be given to you? What should be given to you? The elements of X and Y matrices. Elements of X and Y matrices. Before this, you should also know what is the dimension of each matrix. Dimension of matrices. All the matrices should be of the same dimension. Okay? Dimension of the matrices, elements of X and Y matrices. Then what is output? What is that you are going to get out of this program? Okay, the output is you have to generate the matrix Z. What is that? Which is the matrix Z, which is, what are the elements? Which is the sum of corresponding elements of corresponding elements of X and Y matrices. Okay. So this is what we are going to write. We are going to add two addition of two matrices. The input is what is the dimension of the matrices? What are the elements of X and Y matrices? Output will be we have to generate the matrix Z, which is the sum of corresponding elements of X and Y. Now, so what is our algorithm? What is our algorithm? So what is the first step of our problem? What is the first step? First step is take dimension of sorry, dimension of matrices. All will have the same dimension. That means what is the variable we will use? M and N values. Okay. What is the second step? Take elements of matrix X. Okay. Then you also require the elements of matrix Y. Take elements of matrix Y. What is the third step? I know the elements of X, I know the elements of Y. So generate matrix Z. Okay. How do I generate? So how do we generate the matrix Z? Add the corresponding elements of X and Y. Okay. Then display Z so that you can see whether the result is correct or not. Display Z matrix. Okay. These are the steps in my algorithm. Take the dimensions of the matrix. All of them will have the same dimension. And then you read the elements of X, read the elements of Y. You read them separately at the beginning. Later on you can have element of X followed by element of Y. Let us not go into that because when you develop an algorithm, you have to develop in a simple method so that you understand the logic. Then generate the matrix Z, display the matrix Z. So what is our first step now? Take the dimensions M and N. Okay. So I will take N are the two variables, simple variables. X, I will take 5 by 5 matrix. Okay. Y will also be of the same dimension. So let us take Y also to be 5 by 5. What is the matrix Z? Z will also be of the same dimension. Okay. Now we have declared only variables. What is the first step? What is the first step in the algorithm? Take the dimensions M and N. Okay. Printf, enter dimension of matrices. Okay. We will take it from the user. How do we take it from the user? Scanf. Okay, I want to take two integer values. M and N are integer values. Ampersand M, ampersand N. Okay. Ampersand M and ampersand N. Now, this is the dimensions I have taken. Then, what is the second step? Second step is take the elements of matrix X. Okay. So, I'll again give a printf statement. Printf, enter elements of x. Okay. Before this, I'll just give /n so that it will go to the next line. Okay. Now, how do I take the elements of x? It has m rows, n columns. For I is equal to 0, number of rows less than or equal to m minus 1, I plus plus, okay, m rows. Each row has n columns. J is equal to 0, j less than or equal to number of columns minus 1 because subscript is 0 to n minus 1. What is that I want to do? I want to scanf. I want to read the elements. Each element I want to read. Okay, %d, comma, each element of x, x, I, j. Okay, so this is for reading the elements of x. Similarly, let me write separate for loop for taking the elements of y. Printf, okay, /n, okay, enter elements of y, okay. Now read the elements of y. Again this requires nested for loop because y also has number of rows and number of columns. I is equal to 0. Number of rows in y is m. The subscript is minus 1. I plus plus. Okay. Now for each row I have to read all the elements of the column. J is equal to 0. How many columns are there? N number of columns are there. The subscript is, last subscript is n minus 1. Okay. What is that I want to do? Scanf. Okay. Each element you read, comma, ampersand y, ij. I am reading the elements of y. Okay. This is all you know how to read the matrix. Now, I have to generate the matrix. Okay? Generate Z matrix. Okay. How do I generate Z matrix? Z again has m rows, n columns. So, for I is equal to 0, how many rows are there in Z? M rows are there. So subscript is m minus 1. I plus plus. Z also has m rows and n columns. J is equal to 0. J less than or equal to n columns are there. Subscript is n minus 1. J plus plus. Now how do I generate Z? Each element I. What is each element of Z? Zij is equal to, what is the formula? Xij, okay, plus Yij. Is that alright? Okay. Please mute your audio. Do you follow this? To generate the matrix Z, Z again has m by n is an m by n matrix. How do you generate Z? Each value of Z is equal to the summation of the corresponding elements of X. Now let us display Z matrix. Okay. How do I display Z matrix? Z has m by n row, m by n dimension. Okay. M number of rows for I is equal to 0, I less than or equal to how many rows? M rows. Last subscript is m minus 1, I plus plus. This is for number of rows. What about columns? How many columns? J is equal to 0. J less than or equal to n is the number of columns. Subscript is, last subscript is n minus 1. Okay. J plus plus. What is that I want to do? I want to display. Printf. Okay. Printf. Each element is an integer. Okay. Each element is z of I, j. Okay. Z of I, j. So after displaying one row, I want to go to the new line. That means for each row, display all the columns. Display all the columns. How do I display all the columns? J is equal to 0 to n minus 1. After each value, I am giving the space. Please observe this. After each column element, I am giving the space. Okay. That for loop will display all the columns. After all the columns of the row are displayed, go to next line. Okay. Go to the next line. Okay. This. Okay. Now, so for displaying the Z matrix has m rows. Each row has n columns. Display the rows by giving a space. Display the column elements by giving space after each element. After the entire row is displayed, this for loop will display the entire row. Then give the new line. Okay. So each row will be displayed in a new line. Okay. Okay. Let us. So do you follow? The first step is take the dimensions of the matrix. Next step is take the elements of the X matrix from user. Then take the elements of Y matrix from the user. Third step is generate the Z matrix. Then display the Z matrix row by row. Let us execute this. Okay. What is missing? I have not declared I, j variables. Let us declare the I, j variables. Okay. Enter the dimension. Shall I give 3, 4? 3 is the number of rows. 4 is the number of columns. 1, 2, 3, 4. First row. 5, 6, 7, 8. Second row of X. 9, 10, 11, 12. So matrix X is over. Now let me give the Y matrix. Y matrix is 10. No, let me give, okay. So, okay, 10, 11, 12, 13, 14, 15, next element, next row, the third row, okay. See here, there is no gap after this. So what should I do? Before displaying the Z matrix, you please give one new line, or you say the Z matrix is. Let me, because after the y elements, whatever the z values you got are correct, but you are not able to identify what is the z matrix. So what we will do is, before displaying this, I'll give one printf, the z matrix is, okay, and I'll give one new line, go to the new line, so that the output is clear. So before this you give one new line,